Hello fellow process designers, it is Abjoy Babatunde again for this channel, Nobel Process Designer. How are you doing, guys? Hope you're enjoying our video. Hope you're gaining knowledge on how to use chemical process design software like Aspen HYSYS, Aspen Plus, AutoCAD, and 3D GAMS. Although I've been seeing some of your feedback, some people actually send message to me, and I'm really encouraged to do more. You understand? I'm really thrilled. You understand? I'm pumped. Like, you guys are really seeing some things. You are gaining some knowledge and it's helping people in their projects. You understand? People send message to me all over the world about the content. You understand? About what I'm doing. So I've been seeing positive feedback from the comment section. So I'm really impressed. Thank you. So today, to cut the show short, what we are doing is we are doing advanced petroleum characterization in Aspen HYSYS, and I'm going to be using different kind of crude blends on. I'm going to be installing it, and I'll be checking the result based on the product that we can see. You know, from refining of product, you can get different kind of product like naphtha, kerosene, diesel, AGO, and atmospheric residue. Yes, and so I'm going to be comparing those results from this crude that we have here and another crude that I'm going to create, and I'm going to be creating that crude in a more advanced way than the way I did in my previous video on the basics of petroleum characterization in Aspen HYSYS. So I'm going to be checking things like the operation condition, that is the reverse ratio in the atmospheric distillation column, the boiler duty, you understand, and the reflux rates and the vapor off gas rates that we can get from the distillation column, and the naphtha to residue ratio, that is the amount of naphtha that we can get. On this, we can only get 581.8 kilomole due to my condition. You know, you can see the meaning of simulation is for you to adjust process parameters, and get which kind of parameter you can adjust to get your spec, your product spec, you understand. But this is just like a rudiment simulation. Just I want to show you guys the effect, how things change, you understand, what it can cause, you understand. So like based on the kind of feed that you are inputting, characterizing Aspen Plus, how it can affect your product, you understand, and the product that you can get to do. So that's what I want to show you today. So we're having kerosene, we're having diesel, and residue here. So I'm going to be finding the ratio of the two, and for the next assay blend that I input in I will install in this stream, I'm going to be showing you the changes, you understand, the difference too. So just take note of this to be 581.8 kilomole per hour, and this is 470, you understand. So, and this one is 1.97 E4. So that's all the thing. So although I'm not going to save this, so I'll just show you the compare. So the operation condition is like, if you want to check the operation, you can get to performance for this one. So the performance is, well, I can see that this reflux ratio 2989 kilomole per hour. So although this if you want to go inside this distillation column, this is not having a reboiler. This is like a steam strip absorber column, you understand. That's how they used to design atmospheric distillation columns, you understand, so that is a stream at the bottom, you understand. It is having 29 stage and there are 3 pump around, you understand. So and there is 3 side stripper and 2 is stream strip side stripper and 1 is reboil side. That's why you're having this reboiler here, and each side stripper you are getting product at the bottom. We are having this two at this bottom, we are having kerosene here, and we are having HU here. So this is the condenser, you understand. So we are having this our condenser, and inside the condenser there is water. Okay, there is naphtha stream here and there is water drop. You can see the water drop here. Oh, you see this, that is, I don't want to be arranging this today. There is water draw here. This is water draw here inside the condenser, you understand, to remove water. And this water flow is 317.4 kilomole. So that's that. So I'm going to be doing the new assay now. So to do the assay, you have to go to the property environment. So this is the assay here, and this is the plane for the assay. So I'm going to be removing the assay so that it will not calculate the assay, and there is no component for the assay. There is no component generation, you understand, again. So I'll be able to edit it to a new assay here. So I'm going to call this new assay that I'm going to edit it to be heavy crude, because I'm going to be using like 3 kind of crude: heavy crude and light crude. And okay, let me even show you. So these like 3 kind of crude, and this heavy crude, they have actually analyzed the data, like try and bring the data around so that it should be easier for me to copy, you understand. So the data is actually from all these things. So I saw this one is from ExxonMobil. So you have all this one, you can download it from their website, and it's just for rudiment simulation. If you want more accurate data, you can get it directly from the laboratory yourself, you understand. So so we have this boiling point. So I have to copy it and send it to the sheet so that it will be easy for me to send. So for this is another crude, Bonga 15S. This is like a medium crude that I'm using for the medium crude. So this one I want to be using this for the light crude, because this is very light. You can see the last boiling point is this is like a low boiling crude. You understand, the last boiling point is 1352.7 Fahrenheit, while the API for the crude is 42.7. You can see very light. So, and for this 28.6. So this is like a medium crude, and this one is 1394. That's the last one. Okay, so I had to just copy all this data that I needed, because you can't put all the data there. It's only when you are doing rigorous calculation that you put all the, the more data that you put, the more accurate your result is. So I have to analyze all the data here. So this is the data I'm going to be using. So let's get started. So now I've changed the name to a new code. So I'm going to start to adjust the code now. So for this data, I'm trying to input this kind of, so we have boiling point with percent in mass basis, and we have the density in pounds per feet cube, you understand, not in API. We have the lighting analysis for this one too, and the sulfur analysis. Okay, so for this I'm going to start by changing my assay definition to suit the data that I have. So we are going to be using bulk properties. We are going to be inputting the lighting composition. So the molecular weight, we don't have data for it, so I'm going to put it in not use. So this one is okay. This one is also dependent. It's because the data here is the same thing. You can see this, the basis of the data here is basics. The density is basic, you understand, or the same thing as the true boiling point data, you understand. So it's going to be dependent. So I'm not going to use viscosity because I don't have data for viscosity, and my true boiling point is atmospheric, not vacuum. So I have to pick it like this. So the next thing is to delete the molecular weight that is given here. So I'm going to change this one back to the value that I have in my data here. So this one is 55.2. Though you can easily copy it, and because you know there's still some decimal fraction that might be needed, so it's better to copy than to type in, you understand, so you can be accurate. So just leave this one like that. So the next thing is to do the light analysis. Let me change this. Okay, I'm going to change this one to mass percent, you understand, because lighten is in mass percent basis. So which percent, so using mass percent. So I'll copy it and paste it on my composition table so to calculate the overall. So I think that's it. So we go to distillation, change this one to mass. So we edit the assay. This one is having how many data, but I guess it's having enough data, but it's not having it, just copy. The last value is not having a variable. It's not too much to copy all the value, just have like 6 points that is needed, you understand? So, but the more points you have, the more accurate your result is. So I'm going to copy all the data. So I think you have copied everything here, and temperature is in Fahrenheit. Take note of temperature value, Fahrenheit, you understand? So, okay, that's that. Then we do for the API, the density. So I'm going to be copying the density value. You can see, because I make it dependent, it has already filled up the percentage for me in black dots, so I don't need to be filling by myself. So I'm just going to put this one there. Just going to copy it. It's not fit. Why is it not fit? Oops. I'm copying this stage. I have to copy this one. Okay. It's just a mistake. So okay, we have this. Okay, now it's fit. So we have that. So I think this one is done. The next thing is to do the sulfur. I think you have to do sulfur with a user property. So, but we have not declared user property for Aspen HYSYS simulation. So I have to declare the user property first. So I'm going to do that one in this tab here. So I'm going to add a new user properties. So I'm going to be calling the, okay, let's just set it up first, mass fashion. And this one, yeah, just the mixing parameter. It's just like mixing rule for property, you understand? So, but it's since it's max version, all the default has been set, you understand? Because the basis for sulfur property in the assay is like mass percentage, you understand? So it's mostly like mass fraction too. So we have the mixing parameter. So just leave these at default value for now. You can see all this. This is the equation here. So this is the period of the mixture, you understand, will be equal to this parameter plus this one. So this one is just like to adjust, you know, that there are different kind of standard for mixing rules, you understand. So you can be adjusting the value in order to get that equation that you want for the mixing, you understand. But just leave that default that it is, you understand. So the value for the pure component, I'm just going to see, you know, sulfur is not in water in reality, you understand. So and it's going to be 0, you understand, and methane is going to be 0. So you just put the value to be 0 for the pure components. Yes, so you can just use it in your model. So I'm going to be changing the name to sulfur, so it will be easily distinguishable. Sulfur. Okay, did I get the spelling or not? Okay. I didn't get it. Okay, it's okay, that's sulfur. So it will change it later. Option. Let me write it again and press insert. Okay. Sulfur fraction. It's saying the name is not unique, so let me give it sulfur fraction. Okay, nice. Maybe sulfur is in the code in the back end, you understand, like in the working code, is because you are going to be checking the trace message here. You can see the name is not unique here, understand? So that's how you know like the trace message is this way. As you are doing calculation, like you work in Aspen HYSYS, you are going to be saying your this is like a what's the feedback, the output from the programs, you understand? So let me go back. So you now see it's in the available user property. So I'm going to add it now. So this one is dependent. So I'm going to be saying the lower limit and the upper limit to be 0 because it's in percentage, you understand? So 100 and 0, you understand? So so I'm going to copy the value here. So we can get the bulk value here. So for bulk value for the whole code is okay when the experiment is done. So then I'm going to write the table here. So that means I'm done with first assay from there. Okay, this one is done. So I'm going to add another assay. So I'm going to use bulk value. Okay, let me give this one a name. So this is the let me write the tapis. Tapis is actually from where is this place? I've actually forgotten the place where it is. I think it's from Morocco or something. So that's the tapis here. So true boiling point. So light end is auto calculated. Okay, so I want you to calculate the light end for us based on the value field. So we have the meaning of auto calculator is the pure component that we put in the simulation are what we tell us that is the light end component, you understand? So it's going to calculate the composition. Assuming I put ignore, it's not going to calculate the composition for those pure components, you understand? So that's why I put it auto calculated. Although from the data that I have here, okay, from the data that I have here, this is the second one. I have the fraction of the lighting, like all the lighting, but I don't have the individual analysis for the lighting, you understand? So that's make it different. So that means I can do the lighting calculation. Why is this thing blinking? Okay, so we have the molecular weight is not used. So this one is independent. Yeah, it's independent. I'll show you why later. So let's start with the block property. So let me just set this one up first. So we don't have the data for the molecular weight. You can see this value is different from this value, so they are independent. Like the basis for the other curve, you understand, independent curve, like apart from the distillation curve is different, you understand, like the volume cuts, you understand, different. So I'm going to start with the bulk property API gravity. Okay, before I can do this one, let me copy it first. I have to change the density value to, because I don't want to be copying it in API and say yes, because I have to be doing it I have to do in the plot, and to take a lot of time to be changing the units one after the other. So let me just change the unit to API directly first. And to change the unit, you go to the unit of measure, go to option here, go to unit of measure, and okay, it's already in. So you look for density. Like there are two densities. We have the standard density and we have the mass density. So you're going to look for two. So I'm going to look for standard density first. Standard density. So yeah, I've changed this one to API. Then you look for mass density too. Look for mass density. So change the two to API. So I think it's done now. So I can now copy my value here. Okay. So it's in API 60. So to leave it in API. So this one is the temperature given here is what you see. The temperature is 104 and 302. So you have to use this temperature for the basis that you are inputting your viscosity data. So 104 and 302. So I'm going to change this one to 104 Fahrenheit and this one to 302 Fahrenheit. So let me change the rest to this one to liquid volume. Why is it not changing to liquid volume? Light end to liquid volume. Okay, liquid volume. So viscosity to 104. Kinematic viscosity data that we have. So this one to 302. Okay, so this is kinematic viscosity. So I'm going to be putting the bulk value now. Bulk value at 104 Fahrenheit before they do the cut value, because the component, all the components have different viscosity. Crude oil contains a lot of components, but the overall bulk value viscosity, that's what I'm inputting now. So you have this for the two. So let me check, am I using the right crude? Okay, tap this. Okay, just to check over and again. Yes. So I think this is done here. So we have to lighten analysis. So we have already put it in auto calculator, so it should calculate the value for me. So this one too. So it's going to use, you can remove the component that you don't want to use. So because I want to use all the components, so I have to pick all. Yeah, you understand. So distillation. So let me put the distillation data. So let's just input the value here. I'll write 10 points. I'll add 10 points here. So copy this one. Right now we have a more detailed analysis, tube boiling point analysis. Oops, it doesn't get to 10. So I have to add 2. Okay, I think it's just 2. Okay, I had to add 2 more, like 12. Okay. Okay, now I got to the value. So that's it. So density curve. So how many points should I add? 1, 2, 3, 4, 5, 6, 7. So we're adding 8 points for density. Okay, let's add 7 points for density. So I've added it 7 points. So that's the density curve. Let me cross check again. 120. I want to check for the distillation too. 1353. Okay, I think it's correct. So density and distillation is done. So the next thing is the viscosity data for 104 Fahrenheit. So we're adding 7 for this one too. So I'm going to copy data and put it into the simulation. Done. So for the last curve, add 7 points. Okay. So now that we have this, the next thing is the sulfur content. So let me do the sulfur content, then we move to the last assay. So this is the sulfur content. The bulk value, I'm going to put the bulk value. Okay, this lower limit and upper limit has been done. So for this, I have to be doing it one after the other. Oops, that will take a lot of time. So I'm going to pause this video after doing one. So I'll jump to the end of the procedure. Okay, I'm done with the steps. So I've copied all data from this place one after the other because there's some kind of, you cannot add points here and it will return an error if I want to send everything at the same time. So I think this assay is also done. Let me just check again. So kinematics, okay. This is also very important. This is in liquid volume. So the basis that you set for the distillation and light distillation will be the basis for the density, viscosity, and all the curves that you send. You understand the basis for these cut points. Assay cut points. This will also be in liquid volume percent, and viscosity will also be in liquid volume percent. You understand? So you don't have to worry about the basis of this one. So set the basis in the distillation curve here to be liquid volume. You understand? So we add the last assay. So in order to make it shorter, I'm going to copy this assay and just paste it as a new assay. So I will name this one to be longer 15x. Okay, so this is my longer 15x assay. So I'm going to be adjusting the parameter one after the other. So it's the same thing, but just have to change the parameter. So I'm going to look to the tab. So the work value for density, I'm going to copy it. Okay, 28.59. Okay, 28.59. This viscosity value, that's the next thing. You know, this viscosity value is centistoic, so just be mindful of the value. Viscosity and the viscosity as 302 Fahrenheit. So okay, so you move to light end auto calculated, same thing. So distillation data, I'm going to edit the distillation data, copy the value here. So it's a little bit faster with these steps that I'm taking. So it has edit the value. So I'm going to edit the API that gravity curve too. Okay, this one too is done. So the next thing is viscosity curve. This one is to tell you if you want to use just one curve. So, but we want to be using two in order to get more accurate result of the characterization process. So that's why I just put the two curve. So I'm going to copy this one, paste it here. So for the second curve, doing for the second curve, edit the assay, then copy and paste. So then user property for this one, just change the user property data for the sulfur and all this kind of thing. So that's that. So I'm going to change the user property data here. So and the assay data. Okay, this one can be done once because the data is already there. So I'll just copy it to it. Assuming I just create a new data, a new assay is going to take more time to do. So as you are working, you understand, you also learn how to work faster. So I think that's that. So the next thing is just the meaning of this is independent curve assay basis. Like the basis for all this assay percentage, you understand, is at mid cut point. That is, look at what I did here. Let me show you what I did here. Look at this cumulative cut point. Although from the data I'm having, the cut from butane, this is like all this butane and lighter, the propane, the pure components, you understand, light component, light ends, you understand, while the light naphtha cuts of the assay, you understand. So it's from this data that I'm saying the cut point, you understand. So I have to make this value, the cut heat volume percent, you understand, into mid volume percent. You understand? Assuming I want it to be cumulative, you understand, it will be this value that I'm going to be using, 1.9, 8.9. You can see this value is the same thing that you are seeing in the, okay, let me show you for the last one that we just did, this regular code. Okay, you can see it's 95.6, 0.4 that you are saying in this point, 0.4, 95.64, you understand. So you can, this is mid volume percentage, you understand, so they are independent curve, you understand. So but assuming I want it to be all this, I want to be endpoints, you understand, so it's going to be the ending, that is cumulative, then addition. This one is the first 0.9, then this one plus this one, addition, you understand, addition of the cumulative points, do you understand, that is 4.717, you understand. This one will now be 100, you understand. So I'll be using this value for this assay percentage, assuming I pick endpoint. So don't be confused with the two value curve percent basis, you understand. So that's the meaning. So I think the next thing is to start calculating the assay one after the other and checking your results. So this one is calculated. So you can check the working curve here. Okay. So it's a working curve. Okay. You really can plot this. Okay, you can plot this too. This is the sulfur distribution curve. Okay, that's getting from the assay. So I'm going to calculate this assay too. So you can compare the distillation and the sulfur distribution curve for different kind of the assay, you understand. So can be rest assured how to remove the sulfur, you know, how to take note of the sulfur as we are doing the simulation. So I'm going to calculate this last one. Okay, you have the working curve, the most cumulative most, and the normal boiling points, you understand, from the assay. So you have the plot, distillation plot, you have the curve. So this is the viscosity curve, density curve, that input. So sulfur curve for this assay. So let's take it to the blends, you understand, to blend that so that you can blend it. So I'm going to be adding all the crudes to the blends. So this one is, I want this one to be, let me check. Okay, so I want this to be, let's make it in mass basis. And so this one is going to be, I'm going to make flow rate to be like, it's just like a fraction, so don't be confused about the fraction or something. So 1 is just the ratio of the crude that would determine how important the crude is in the weighting factor of the crude, you understand, in getting the component, you understand. So the more the crude you put the crude, the more it will influence the blend, you understand. So, and we have the every crude is, let's make it to be 3. Maybe we have a lot of this every crude and want to make some light components so we can get some naphtha. So it has calculated automatic. Oh, okay, there is something to that we should be concerned, is this cut edge. I think you understand how to use this one too, but the first one is auto cut, which will help you to cut your assay with a certain corresponding standard for cutting with the initial boiling point and the final boiling point of the crude oil. You understand, there will be some range and the amount of cut that you can see. Then you have the user range, that the one I'm using currently. So this user range will be waiting on this cut end point temperature, you understand. So from 100 Fahrenheit to 800 Fahrenheit, we are going to be having 28 cuts. So I want more light components. Maybe I'm doing my analysis, you understand, to contain a lot of light components, you understand. I want to be seeing how those light components is changing. So for the heavier, you understand, like residues, you understand. So we're having 2 here. For I, we are just having 2 components. You know, most of those every component is lighter. The more component that you can get from your blend, the more accurate your simulation is, mostly, you understand. but to increase your calculation speed here. So if you are not really concerned about what's happening, you can reduce the amount of component that will be generated within those range, boiling point range, or from the assay. You understand? So you can click on submit. Sometimes it's automatic calculation. You understand? So this is my crude oil. This is the lower temperature limit and the higher temperature limit. So yeah, so between this range, you can see it's going to calculate it. So we have this. So now we have the result. So we can go to tables and see the components. So these are the components that it's being generated, and it's based on their boiling point, normal boiling point. You understand? So you're having some kind of component. I can't count it. So you can see the composition. It will include, this one will include the light end composition. You can see the water composition of the crude oil, the propane, isobutane, normal butane. So this for the blend, and you can see for different kind of all the crude oil. Yes, so you have the property first. So you can plot the two boiling points for the properties here. Okay, different kind of, let's just plot two boiling points for the crude. I want to plot, and this one will contain the crude two boiling points and the rest. So you can see the two boiling point data for the crude, and you can put another data here, like make the data to be merged. You understand? So we have the distribution curve, and you can see the basis now, mass basis, mole basis, different kind of basis, more fraction. You see. So liquid volume basis for the true boiling point. So we have the data here, straight run. So this one is composite plots. You can do a lot of plots here. These are purposes for the blend. So I'm going to plot the sulfur for the point. So this one will calculate user property for the individual item. So it's only there unless you're having data for the lighting, user property data for the lighting. So we have this one. So I think we can go to the simulation environment now and see because let me check if the oil is being installed, because I'm not sure. Okay, the oil is installed in this stream blend here. So you can still install this blend on Bunga crude. You understand? This crude oil divided the ratio. You understand? Like this Bunga, assuming this is only this Bunga in the stream. You understand? Bunga 15 so every crude your tap is light in the stream. So you can still install those two in your simulation. You just click on install here or here, write a name on the here, then to install the stream on yours. Is to install the stream on your simulation. So now I'm done. So I'm going to check my stream. Okay, so you can see the composition now. Oops, it does not calculate the composition or something. I'll check it back when I activate it. Okay, let me check something. I don't know. Let me check something from these properties. For each feed, you have to check the composition of the blend first. Okay, let me try and reinstall the crude oil. I'll try and reinstall it now. Okay. Okay, now it's not working. The composition is somehow wrong before, so I have to check and reinstall it. So let me change this one to the flow rate is, I'll change the flow rate now. It's 101 barrel, 500 barrel per day. So I'm going to copy. Because I changed the flow rate, so let me delete this one. and specify the flow rate here. I'll copy it again. Okay, it does work. So the simulation has converged. So now we can see we're having more naphtha flow in the product, and we're having more residue too. Or we can adjust these parameters here and get, let me see if we can adjust. Let's see if we can adjust the, okay, we can't. Okay, we are getting more residue, and the ratio has adjusted. This is 983, this is 702. You understand? If you get the ratio will be higher, and we have off gases too. We have kerosene, and we have diesel and AGO. So I think that's the end of this video now. We have seen how to do advanced petroleum characterization in Aspen HYSYS. So I'm doing more analysis, but it's just a lot of things. So I will just have to take it one after the other. Yes. So we have the preheat crude, and the naphtha flow rate has increased, and the residue ratio has reduced, and the reflux ratio has reduced to, check, the reflux ratio is 3.2 now. You understand that it's more linear operation, not like before when it's like 5 reflux ratio. And if you check our reflux now from this place, it is 3159. Yes. So we have this. So the temperature for the condenser and the pressure, you can see all those data here, the profile here for the stream and for the distillation column. So watch out for our next video. So it's going to be about petroleum refining process. I'm going to be doing some analysis on petroleum refining process and how to use petroleum assay. So thank you for watching. See you next time.